We might want to wait a couple of minutes for people to get on the call. It takes about 5 minutes.
No worries.
Let's see. Oh, I'm giving a summary. All right, then. Good to know. I should prepare summarizing. Alrighty. So we have Michael and Mike from Couchbase. Do you go by Michael? Michael, is that how you guys differentiate?
Yeah, actually, I think so. I'm the Michael, and Mike is Mike.
All right, that makes it easier. Oh, you're muted, Chris.
There are actually two more from Couchbase on the call.
Oh, great.
Yeah.
Sweet. Hulu. Thank you, whoever is managing the attendees. Let's see. 8:35, right on the money.
Perfect.
Later.
All right, that looks like a good quorum of people. Hello, everyone. Welcome to Friday. Welcome to the OTSC call. Great to see all your lovely faces. We have a pretty cool call today. We've got the Couchbase team here in force, and Mike and Michael are going to present the great work they've been doing integrating OpenTracing directly into their libraries and products. Please make sure you add yourself to the attending list. Looks like everyone's doing a good job of that right now. And yes, Matt, we are recording this. So this will go up on YouTube on the OpenTracing channel when we're done. And on that note, Michael, you want to take it away?
Yes. Can you hand me the baton? All right. I think I can just share my screen. Can everyone see it?
Yes.
Okay, perfect. So let me jump over to the slides here. All right. So thanks everyone for joining, and everyone who is watching the recording in the future. A slight correction. So I'll be presenting this alone. Mike had his hands full with other stuff. So, but he's around for any .NET and other related questions. But you'll just have to bear with me for now. So yeah, my name is Michael Nitschinger. I work for Couchbase as a software engineer. And lately, the last couple of months, amongst other things, been knee deep into what we call response time observability, which of course also feeds into the whole OpenTracing theme, which I'll talk in the next couple of minutes. And then we have a demo, and yeah, then I think we can just easily open it up for questions. So I'm going to tell you a little bit about Couchbase, just a couple slides for those who haven't heard it before, what we've been doing. Then the challenge which brought us into the whole OpenTracing, distributed tracing theme, timeouts. Then what we've done with adopting OpenTracing, the good and the challenging pieces. Then a live demo, and then a call to action, and then we can do some questions. All right, so what is Couchbase for those who haven't heard it before? Basically, Couchbase is a distributed document-oriented database focused on scalability and performance, right? So that's the one-line sentence of what Couchbase does. And so it has all kinds of properties like auto-sharding, a flexible data model. But I think for the purpose of today's call, what's important is that it has a memory-first architecture, and everything inside the database itself is also done asynchronously, right? And we'll see how that works in a second. And the other thing is that you can scale workloads independently. And if you look at Couchbase from where it's coming from, right? Originally, years ago, it basically was a distributed managed cache and a key value store. And then it evolved into the document database theme. And it has been adding other things like Couchbase Mobile, a Nickel query language, which is very SQL-like. We added full text search. Now we're adding analytics. So you can see there are like more and more components being added to the system, which you can immediately think that it's probably not going to make it easier to troubleshoot performance issues, right? So, but just that you get an idea, this is where we're coming from, basically from being a distributed managed cache and then adding functionality towards document-oriented analytics, full text search, and so forth. And one thing to call out here is that one interesting property of Couchbase is that it supports what we call multi-dimensional scaling. So you can basically enable every kind of service, be it key value, be it full text search, querying on every node in the cluster, but you can also choose to only enable individual services on each node, right? So you can say, okay, I have a 50 node cluster. On 2 nodes, I run the query service. On the others, I do indexing, and then I have a couple other nodes where I store the data, right? The KV service. And the important piece here is that on the client side, our SDKs are actually like intelligent, right? They don't just take your data dump and send it to a remote socket, which happens mostly with relation databases, but the SDKs play an integral role as part of the distributed system. So they basically get cluster information in near real time, basically get an update of the topology, and then they decide when a request comes in where to dispatch it to, including handling certain retry scenarios when you are rebalancing the cluster, and rebalancing means you can add and remove nodes on the fly without downtime. So that's another challenge that the SDKs handle, right? Making sure the data gets to the right places at every point in time without user disruption, right? And here's an example of how we would do write operations. So for example, you create a document in your, let's say, Java application, and then you call the upsert method on the SDK. What happens is, of course, we send it over the wire to the server, and then it lands in the managed cache, our KV layer. And then the managed cache, once it's there, it will basically acknowledge the write to the application itself. And then it will asynchronously send the operation to the replication queue, asynchronously to the disk queue, asynchronously to the secondary indexing engine, right? So all of these steps are happening asynchronously. And obviously, they can also happen over the cluster, right? So the replication queue will eventually send the operations to the replicas on other machines, right? So even if you just perform a single operation from an SDK point of view, many different spots in the distributed system actually affected. And when we come to the point where something is slow, right, we need to figure out which places in the distributed system have been touched and where the slowness comes from. And the other operations are the same, but I just didn't add more slides since it's similar. But if you have questions on specific functionality of Couchbase, just let me know and we can cover that later. So with that basic knowledge in mind of how Couchbase works and operates, what's the big challenge, right? And the thing we've come across in the years, and I've been with Couchbase for many years now, and we've been handling support escalations. And one of the bigger problem or the bigger challenge users and customers are running into are timeouts, right? And the problem is everyone who has looked at timeouts and worked with them and tried to figure out what's going on, the realization is timeouts are always the effect but never the cause, right? Timeouts are the symptom of something being slow in the system or taking longer than expected. And that's something that realization hasn't happened to lots of users out there, right? They see a timeout and they think the problem is the timeout, right? So one of the steps or one of the important pieces here is to help users first realize that timeouts are not the real problem and they need to go deeper and figure out what caused the timeout in the first place. But then also give them the tools and functionality in their hands to actually go troubleshoot it. Because one of the challenges with, for example, the current Java SDK, but it's similar in other languages, is that here in this stack trace, the user has been performing a GET request, so just fetching a document, right? And what it get returned was a timeout exception. But the problem is just with the timeout exception only tells you, well, something was slower than expected. The deadline you gave it as a timeout value, basically, it took longer than this timeout, this deadline. But it didn't tell you exactly what went wrong, what went slower. And then it's very hard to troubleshoot, right? The next step, most of the time, is go look at the logs, figure out if you can see something, go fetch information from the server to see if something's slow there and so forth, right? So a very iterative process, explorative process, but also sometimes very time consuming. And making that time slower to basically go from something went wrong to detecting what went wrong and exactly how to fix that, right, is the whole purpose of the response time observability. So common causes, obviously there are three players or three components in our distributed system, right? There is the app servers, and there can be many of them. And then we have the network, and then we have a cluster of Couchbase nodes. And each of them can have several causes. So if you look at the application server, right, at the very bottom you have the networking card, and then on top of that you have the operating system with potential many different layers of virtualization, including Docker, Kubernetes, whatever, right? So that doesn't make it easier to troubleshoot what's going on. And we have seen weird bugs at the OS level. Yeah, I don't want to go too deep into that, but we had issues there as well. And then obviously you have the runtime, right? So if you develop a Java application, you have your application server, at least your JDK, garbage collection, all the fun things that you have to troubleshoot. And then inside your runtime, you have your application where something can go wrong, logic problems. And then inside the application, you have the SDK, which can also have bugs, right? No code is perfect. So you have all these causes on the application side. And then if we go down the layers, we get to the network. And then you have firewalls, switches, load balancers, proxies, all causing latencies, maybe in batches, maybe, spontaneously. We have seen firewalls dropping packets, firewalls basically black holing the sockets, neither telling the server nor the client that the socket got closed, right? Operations going into the void, all these fun things on the network. And with shared networks on EC2 and other cloud providers, it's even trickier. And then once we have all the application and the network handled, then we can look at the Couchbase server cluster. And there everything applies obviously to the OS layer, but then instead of the application server, we have our Couchbase server node where each individual service can cause slowness. Or if you fetch a document, the disk can be slow, right? So it's coming from the KB service or garbage collection in the Nickel query engine, something like that. So then you have all those causes inside Couchbase. And then on top of that, we need to figure out where the slowness comes from with a single timeout exception. And that led us to look around and figure out some ways to make it easier onto our users and to our support folks. And this is what led us to OpenTracing. So we basically sat down and did some brainstorming and figured out some key requirements for adopting a certain API inside our languages. So there is vendor neutrality, because we are not in the business of like application performance monitoring, right? We are not providing tracing implementations, but for us it's important that we plug into as many tracing implementations as possible, right? We don't want to enforce anything specific onto our users. And then for us, it's important also that, at least by default, it has a small footprint. We are bringing in more dependencies, which means potentially there are clashes with other application dependencies, right? The more baggage we bring into the system, the more there is a challenge that specific customers have trouble deploying it and so forth. So we're looking for minimal footprint. It needs to be supported across all our SDK languages that we support. So I've put all those logos here on the side, so Java, Go, .NET, C, PHP, Python, and so forth. So we officially maintain a large array of SDKs, and every functionality that we roll out, we need to provide in all of those languages. So that if you are coming from Java and you're switching over to .NET, you want to feel right at home, you want to have the same functionality. And in large, diverse ecosystems, in enterprises, right? You have different teams running different languages, but eventually, if they settle on the same distributed tracing engine for the whole system, or you have different microservices in different languages, you want to have the same functionality available. And then it should be actively developed, right? It shouldn't be something that we adopt and that it's already there is no adoption anymore right out there. So that's why we settled on OpenTracing, because it's vendor neutral. It supports all the languages that we need for our SDKs. And this is very important for us. It's an API only. No other decisions are made. We don't want to enforce any specific network transport protocol decisions onto our users. We don't want to enforce other implementation details that they want to override or customize in their system. And it's backed by the CNCF, so it has certain momentum, right? It's not like this small one-off solution that users end up building customized code anyways for it, right? So it basically brings all this backing with it. And it's a moving target, and so that's a little challenge for us, right? But the good news is we can influence the moving target, right? We can participate in OpenTracing and move it forward. What I mean by moving target is the versions of, so it's not like there is a 1.0 spec that is basically set in stone. It's evolving, which is a good thing, but it also means that we need to basically keep track of the changes, and then with each incremental SDK version, basically bump the dependencies of OpenTracing to make sure we are tracking it appropriately. So one other key design decision was to implement a default tracer, right? So if someone upgrades, let's say from Java SDK 2.5 to 2.6, where there is OpenTracing support, the user doesn't even have to know that OpenTracing is in place other than getting in one more dependency. And the reason is we want to make it plug and play, zero friction, right? And the idea is that we ship with a default tracer called the threshold logging tracer. And what it does is it's a tracer that is enabled by default, and it aggregates slow spans on a per service basis. So for example, key-value, nickel, all those services we provide, and logs them at an interval. And we have set specific thresholds, but you can tune them. So they are set at, for example, any KB operation that takes longer than 500 milliseconds. Those are aggregated and then logged at a 10-second interval. And then, for example, the top 10 slowest operations are printed into the log with additional information. And with the information that we provide, it suddenly makes timeout correlation possible. So in the timeout exception shown here, it actually changes from a simple timeout exception without context to a timeout exception which gives you an identifier that you can use for looking at the logs. We provide operation ID, the local and remote sockets. We set the timeout. So we suddenly enable the user to look at this information and then correlate it with the log output from the threshold log reporter, right, which is part of the tracer. So every 10 seconds, it will dump out the top 10 or whatever you configure slow operations and give you the same information. And in addition, give you the timings for specific parts of the process, right? Because let's say you have a timer at 500 milliseconds, but the operation hasn't returned. But if 1 second later the operation returns from the server, we can still get information out of it and then put it in your log, right? So in this case, you can see the total time the operation took to execute. The dispatch time is in there, which basically combines the network time and the server time. And then if the server service supports it, it also gives you the server time in microseconds. So for example, if you store a document or you retrieve it from our KV engine, as part of the response, it will tell you how long the operation took. Then we also give it information. So by looking all those different timing spans, suddenly you get this immediate insight into the different timings of the system without before you had this opaque timeout and you had to go figure it out on your own what's going on, right? So, and as in a Java example, this is like the demo setup that you'll see in a bit, but I wanted to include some screenshots in here as well, right? So by accepting a tracer into our client, you can configure whatever you want, right? You can just use our default Couchbase threshold log tracer. You can use Jaeger tracing, you can use Lightstep, you can use whatever you want. And the way you put in your tracer is just the way you do it with the Couchbase Java SDK or any other SDK in general, right? So there is this environment where you just give it a tracer instant and we would use it. So just by changing the environment with giving it another tracer instance, suddenly you go from our built-in zero friction copy-paste logging engine to a distributed tracing engine without for you having to do anything, right? So, for example, here is a screenshot I took from Jaeger, where we are performing an operation called get from replica, where we are basically you're asking for give me the document from the active node and all the replicas, right? And you can see how the parent get from replica operation then has subspans of the get going to the active node, and then here I have one replica configured. So the operation, you can also see how it goes to basically the active and the replica at the same time. You can see how long it took. And then you can see all the spans basically that previously in the log tracer were just fields in the JSON. You can see them as actual spans here. How long took the dispatch to the server, how long took the response decoding, and so forth. That's just out of the box in the system. And then another quick example, here's a nickel query where you can see we are also adding tags to our spans. So you get the component, you get the service that you're running, you get the statement that got executed, specific operations ID, and so forth. So basically storing all the tags along the way, which you can use for filtering and further troubleshooting. So with that, let me jump into a quick demo so you can see the whole thing working. Or maybe, are there any questions so far? Okay, then I'll just move on.
This is awesome, though.
Okay, thank you. So, so you like the demo. So I have just a Couchbase node running locally. So this is our UI. There is nothing fancy. We have two buckets. One is our travel sample bucket, which has airports, airlines. It's just some sample data that you can use for querying. And we'll use it. And then I have a Jaeger instance running locally. And I'll show you how that works. So here we have our code. Can you let me just show it to you briefly, and then we run it. So as a first step, we'll do the Couchbase tracing and then the Jaeger tracing. So other than that, we connect to localhost, give it our credentials, open our bucket, and then we perform a document fetch. Then we will replace the document we just fetched, and then we'll run a nickel query, select distinct type from travel sample. So it will give out all the distinct types that are in the bucket. And then we just sleep a little bit, so we give both the Couchbase and the Jaeger tracer some chance to send it to the remote system. And the way we set things up, for the Couchbase tracer, I've been modifying the report a little bit. So I've been lowering the threshold to 1 microsecond to make sure that every operation actually gets logged, and I increased the sample size from top 10 to top 100. You don't need to do that, but you can see how to configure it. Also setting it pretty to true. You only would do that in debug, obviously, because in a production system, you want to keep your logs short. But we log it in JSON. So if you run something that is taking your log files and putting them to another system, for example, if you don't have a distributed tracing engine right now, you can still make use of the JSON blob and feed it into another system to analyze later. Or for our support staff who can just grab for the stuff and look at things that are slow. Or we configure the Jaeger tracer, we point it to localhost, give it some params, right? So, but pretty simple setup. And let's run this first. Let me get out of here. I'll just run this with the Couchbase logger. And what you can see here is that, so we were doing 3 operations. Let me just, yeah, I can make it bigger. Okay. So that's just, all right. So what you can see is we've been performing those 3 operations: the get, the replace, and the nickel query, and they all show up here in our log, right? So we have the get request. And this identifier, it's maybe not as important to you right now, but what this thing does actually, what we do with, once we connect to the server during the handshake process, we pass this ID to the server. So the server also has like a threshold log of some sorts, and it will log this ID as well. So you can take with this ID and the operation ID, you can uniquely identify any operation in the system on the server side, right? So even if you do not feed this into some distributed tracing engine, you still get the chance to have a better correlation of what's slow in the system. And we see the timing, right? So 20 millis, decode took 9.7 millis, so you get all of this out of the box. Fetching the document on the server, excluding network time, took 49 microseconds. Then we have the replace operation, and we have the nickel operation. And if we do the same thing with the Jaeger tracer, run it again. So you can actually, in the UI, on our Couchbase UI, you can see the so you can see in the bucket statistics, you can see the operations going through. And then if we go over here, find the traces, you see those spans in Jaeger, right, without doing anything. Click on the nickel span, you can see the dispatch to server time. On the nickel, you have all the tags, right, the query just executed, the operation ID, everything basically you've seen in the logging tracer also gets stored here in Jaeger. And we can look at the others like replace. And the other thing is that depending on what kind of operation you run, if it's a mutation, we will span the encoding part. If it's a fetch operation, we will span the decoding part, because we've seen in the past that, like, if you have huge documents, JSON encoding and decoding can take a long time, right? So you would immediately see that as well here. All those things are in place. So I think I'm pretty good on my 25 to 30 minutes. One more thing. I forgot the call to action before we go into questions. So our OpenTracing support is currently in the developer preview. We are planning on a beta end of next week, 2 weeks from now. And then once Couchbase Server 5.5 ships in a couple weeks, months, something like that, this thing will become GA, right? So our call to action right now is we're actively looking for feedback in all kinds of languages. It doesn't matter if you are doing Java, .NET, whatever. We'd really like your feedback on our implementation, on API, what we can do better. Our response time observability, so we have a concept called SDK RFCs. So every feature we develop for SDKs, I would basically put in an RFC where we discuss it. And these are open access. So I put the link in here for the draft. Take a look, put in questions and remarks if you have them. And the other thing I wanted to point out is, so we have a blog at blog.couchbase.com. We're currently working on a series of blog posts on that topic. So watch that space. There is more to come there. If you watch that in the future, you can go there right now since they will be published. With that, thank you very much for spending the time with me, 25-30 minutes, and thanks for the opportunity to let us show what we've been doing for the last couple of months. And with that, I'll open it up for questions. Please, Mike, Matt, Graham, since you're on the call, if there are any other questions that affect you, please jump in. Thank you.
An awesome talk. Thanks so much. I do have one quick question. So, well, comment first. I guess I just said this is awesome, but this is awesome. It's really exciting to see this. And it reminds me a lot of Bigtable at Google had pretty thick clients that did a lot of important logic that was involved in the same sorts of optimizations you're doing. And I recall that that tracing in those clients was essential for the same reasons that you've outlined. I was curious though, from kind of a business standpoint, for Couchbase or for the people using Couchbase, how important are these sorts of timeouts in terms of the support team and so on? Is this like pain point number one, or is this like, where is this on the list?
So from basically working with support team, I can tell you that in general, timeouts are maybe 1 or 2 on the list. So it's a very big pain point. And the reason is that one of the reasons I didn't mention is that, for example, especially on our KB operations, we have a default timeout of 2.5 seconds, right? And some users even set it even lower. And if you compare it to traditional databases where you have 70, 75, or even no timeout, very quickly you run into those timeouts, right? Where in other systems, the thread will just you have to go look at the profiler and see that your threads are blocked. People are running into timeouts with Couchbase way more often just because our timeouts are lower by default, which in my opinion is the right decision, right? Because it's this escape ledge where if something gets slow, you can retry, you can do whatever you want, and we give you back the control. But the average user who is not used to like handling timeouts, especially combined with asynchronous operations, so the Java SDK is asynchronous as well, right? So handling asynchronous retries and so forth. You all need it for running a scalable distributed system, but it's just not something that the average developer is like immediately used to, if that makes sense.
Yeah, the other just to mention a couple of quick things. One of the challenges I guess we have at Couchbase is we are Apache 2 open source, and there's an enterprise subscription, all that stuff. So we certainly have those commercial customers, but then we also have lots of 2 and 3 node deployments. So in those cases, I don't need, sometimes this becomes an issue for them, but they're not always running that kind of full tilt. Others like LinkedIn, they have, they're public reference first, and they have like 1,200 nodes of Couchbase. And they obviously want their site fast. And so getting that observability is really important to them.
And just to clarify, part of the value prop here is not just that you've given instrumentation to your customers, but you wrote this instrumentation with some playbooks in mind, right? So you actually have some playbooks you're going to be giving your customer, or otherwise when they come to support, it's integrated with the kind of hooks and trace points you put into the client.
Yeah, right? Absolutely. One, I don't think I can reference who they are, but one user is actually a member of CNCF and OpenTracing. And they're probably going to implement, they have some specific needs, and they'll probably do their own tracer. And then, of course, there are going to be plenty of both commercial products and projects that people can plug in.
Yeah. My one comment on that is, there's been a discussion about like automated tracing versus manual tracing, which I think is like maybe the wrong way to slice it. And I would like to maybe go forward to talk about there's 2 kinds of automated tracing. there's dynamic tracing, which is the traditional agent-based thing, and then there's pre-provided tracing from the service provider, right? And they're kind of mutually exclusive, right? Because the point of this instrumentation is the service provider is giving you this because they have like playbooks about what you're supposed to do when these things pop off. And that's like
the other thing is that, as you said, Brandon, the other thing is that with like we as a service provider, we just know from history where the pain points are, right? So we can provide very narrow and focused instrumentation on the usual pain points. With if you have some generic tracing, agent-based, right? You're basically you don't have this insight because you just can't learn every library out there 100% and right how the usage patterns are and so forth.
Yeah, I would love us to start explaining this to people about how these are both useful things, but they're just useful for solving kind of mutually exclusive problems.
Yeah, and what we have here is pretty modest. You know, it doesn't do a whole lot, but at the same time, it does. It gives you you know, a fair amount of insight very easily, which was kind of our goal. When we had to, Mike Goldsmith in particular, he and I had to spend a lot of time thinking about like, okay, how do we make sure that we can run this out of the box, not spam the log, still get useful information out of it, all that fun stuff.
That's awesome.
So is this currently done only on the clients, or do you have also backend instrumentation?
At the moment, oops, sorry, go ahead.
Oh, go ahead.
At the moment, it's only on the client. However, we do, and Michael showed this a little bit, we do actually grab certain statistics that are returned in the responses and then put those in. So that was one of the kind of important things that we had actually is that, you know, frequently when we'll see these things, people will wonder, you know, we've seen the one issue Michael kind of slightly referenced. We saw an issue where it was SSD wear leveling, and it would affect nodes fairly randomly, but how do you find it? Because it would be intermittent. And so we needed to be able to see that server side measure of how long it took. The other thing that we did here is there's a correlation ID, so that you can take the correlation ID and then go look at other information on the server side from a logging perspective. That's maybe a little less distributed than we'd like, but it's there out of the box. In the future, we're hoping to carry it further.
Yeah, I mean, I think important to point out is, right, this is not like the end for Couchbase, but this is a first step, and we have more plans, right, to integrate it potentially with the server, have even more instrumentation, right? But this is like the first step into this adventure.
Yeah, and we didn't really show it, but it's also important to us is that the user can do their own instrumentation and have that pass along into our libraries, right? So Michael's shown that in some of the other demos.
Yeah, I wanted to mention that too. I've seen there's a few other databases that have OpenTracing instrumentation, and I think when they get plugged into application code that also has OpenTracing, being able to see that full stack has been quite powerful for those end users.
Okay, so we've got 20 minutes left on the call and maybe a couple other things to get through, but this has been a great talk. Are there any final questions to ask the Couchbase team before we move on? All right. Well, we can certainly continue this conversation in Gitter, and this video will get posted up on the internet so we can start sharing it around, because I thought that was a great presentation, personally. But moving on, someone put update about happenings in the larger tracing community.
I think I put that down. It's my fault.
That's you? Yeah. Did you have something specific there?
Maybe. I mean, I might consolidate it with the item a few lines down around the conversation that we had on Tuesday. I think since the last OTSD call, there was a Gartner report that came out about microservices and APM, which ended up basically saying that the enterprise software market that Gartner studies is moving towards increased adoption of explicit white box instrumentation, and then mentioned OpenTracing by name a couple of times, which is cool to see, and I think reflected reality. That was met with like a number of blog posts from other folks, some of which had varying levels of positivity about OpenTracing and instrumentation in general. That was not causally related to a blog post that Erica Arnold from the OTSC put up a few weeks ago, but it's topically related to that, which just kind of described the different aspects of tracing, which is something I think Ted put on the agenda. But in general, there seems to be a growing need to, like, within the larger tracing community, to describe the different aspects of tracing and name them and specify which problem is which problem, and make sure that people who are trying to solve problem A value that problem B and problem C and problem D are still important. So I think that's the basic narrative that that I would try to play about this whole thing. There's certainly other takes on it that would be a little bit more emotionally driven, but in general, I think of this as like a lot of people who need to understand the value of different problems. To that end, there was actually a very productive meeting on Tuesday that was organized by Alois Wright, sorry, I'm going to mess up his last name, from Dynatrace, and he got a bunch of folks together who, many of whom had been working on the W3C context propagation standards effort, and tried to start a conversation, including representatives from New Relic and AppDynamics, as well as Census and Sergey from Microsoft, around the importance of white box instrumentation without naming OpenTracing by name or OpenCensus by name. And that it was a useful conversation for sure. I think we all, I think everyone agreed that it was very important for there to be a lowercase s standard API for describing transactions that was separate from anything else, which is OpenTracing's charter. And then AppDynamics and Dynatrace, and to a certain extent New Relic, but maybe to a lesser extent New Relic, have certain things they'd like to express at different levels of application complexity. Like they'd like to separate span management from higher level concerns like describing HTTP requests and database calls and things like that. So we had about a day-long workshop to talk about how a lot of that would work, and I felt like it was quite productive and there's a lot of alignment. So I just wanted to say that we're going to continue to have that conversation. If people are interested, you should ping me or Ted or whomever, and all are certainly welcome to participate in it. But I just wanted to let people know that that's happening. I don't like how there feel like there are several different small conversations going on with people from different continents about tracing, and I wish that everyone could just be in one conversation. So this is just my attempt to update that other conversation is happening, and to welcome anyone who wants to take part in it. But in general, I thought it was very positive, and there's a lot of alignment.
Yeah, I would second that and say that conversation kind of dovetails with the W3C working group that is mostly focused on this trace context wire protocol. That wire protocol conversation is important. It hasn't been super directly related to OpenTracing in the sense that we're wire protocol agnostic, but it is important to, obviously, the members of the OpenTracing community. Where these two things start to get tied together more closely is on the other side with a sort of data export format. If you're going to use a standard wire protocol to tie multiple tracing systems together with unified correlation IDs across tracing systems, you're still going to have this problem where you have to get the data out of one of these two tracing systems into the other one so that you can analyze it. So a standardized data format is sort of the other half of that puzzle. And once you're defining the data format, you're getting to something that relates much more deeply to the kind of instrumentation you're doing. The model of that format ideally should line up with the model that the API is thinking about. And then more concretely, the tags and keys and values that the data format is using to describe things like HTTP calls or any other higher level concept really needs to match what that instrumentation library is doing. So I think that's an area where that W3C tracing working group and OpenTracing those projects need to gel up on that side because there is a lot of overlap there. Other people were at that meeting. If people want to keep talking about that, please go ahead. Otherwise, we'll move on.
When's the next one?
I don't know, Chris. When is it?
Well, you can all come to Providence, Rhode Island.
Sweet. All right. Chris is organizing the next one in Providence. So ask him when it's going to happen.
Okay.
Yeah, as soon as another one does get on the books, we will make sure to spread it around the OpenTracing community. So other happenings, going down the list on the agenda, there was an inaugural Austin meetup. This is awesome. I believe this is the first official OpenTracing meetup that has occurred, at least in the US, to my knowledge. There was a meetup group in Austin that was formed, mostly people at, I believe, a HomeAway and Under Armour kind of holding it down. Sorry if I left someone out there. It consisted of a number of talks. I gave a talk. Eduardo from HomeAway gave a talk, and there was a panel of tracing. It wasn't all OpenTracing related, but there were people who worked on the Haystack system at Expedia, as well as people from PayPal, who has had a centralized log aggregator for a while. It's like a tracing system. And so there was a panel discussion on tracing and the pros and cons. My big takeaway was that this is really useful to people. Application developers don't like instrumenting the third-party software that they're given. They don't like doing it themselves. They would prefer that it come with something out of the box, like what Couchbase has created, that they can just plug into. And if it's a third-party plugin, that's great. If it's first-party and comes with a playbook and information, deeper information about what those trace points are trying to measure, that's way better for them. So it was interesting to see users on one end asking for this, and then hearing like this Couchbase presentation around service providers giving them the thing that they're asking for. So that's making me feel really happy. Basically, it was a great meetup. And we should perhaps start more in some of these other towns that we're clustered in. So anyone who wants to start and run an OpenTracing meetup, I would recommend doing it. And just ping me and Priyanka, if you want some help with that.
I'll take you up on that. We'd be glad to maybe do something in South Bay, in the Bay Area.
Awesome. Yeah, the South Bay meetup would be great. Okie dokie. We've got 10 minutes left. We've gone through basically everything. Someone put tracing in 4 parts, talk summary from Ted. So I guess I will talk briefly about that. We've already, I think, covered this. Erica wrote a great post called, tracing. And I gave a talk along a similar topic down in Austin that I would like to turn into a blog post. But pointing out the way I think people have been receiving it well is like there's 4 parts of tracing. I put a link to the particular slide, I think, that shows this. You've got a tracing API that you're using to instrument your code. There's a wire protocol that's standardized to talk between these systems. There's a data protocol that's sending things between analysis systems, and then there's an analysis system itself. So talking about it in those terms, the API, the wire protocol, the data protocol, and the analysis system is a nice way to break it down, because different people are focused on those different components. So depending on your role in this cloud ecosystem, you might find one of these things way more useful than the other. For example, if you work on cloud infrastructure at Google or Amazon and you're providing black box services to people, you really care about this wire protocol and this data protocol, because there's no way for them to install, a Jaeger tracing client in S3 for you if that's what you're using. So the API layer is like not very useful to people who come from that background. And because internally at places like Google, they tend to write all the software from scratch in-house, something like, an agnostic API isn't useful for them internally either too much. So people from that background tend to really, really focus on these protocol level things. Whereas people who are not currently yet trying to glue together multiple tracing systems are less likely to look at this wire protocol and data protocol stuff and be like, that's my big pain point. Without a standard data protocol, how am I supposed to get my information out of Jaeger? And the answer is like, well, I don't know. I just put it all in Jaeger and there it is. So it's fine. So there is a bit of people in the community, I think, sometimes talking past each other because they're just feeling a different part of the elephant. And I would like to get that sort of like cleared up. Maybe us like getting some common language around that stuff. So on that front, I'm going to try to turn this into a blog post to kind of follow up with what Erica wrote, because I don't think we can say this enough. And that's all I have to say on that subject. Look for the blog post. Okay, so we've got a couple minutes left, and we've actually made it all the way through the agenda. Does anyone have any announcements
I think Chris added something to the agenda, possibly.
Oh, you did?
I just added an item because last week, or last meeting month, there was an action item that I was going to change my PR to do trace context header detection on Basic Tracer for Go to have a start with a first step suggested by Yuri that the inbound trace ID in the trace context header would be stored as a correlation, but not used for the Basic Tracer's own trace. And then the second phase could be a separate PR that actually upgraded Basic Tracer to 128-bit. So I'm also going to those W3C meetings, and I wanted to have something to show for both of this group and that group. And so I guess I should just put this on the getter, but what do you think is the method of correlating a W3C trace context trace ID with an OpenTracing Basic Tracer trace ID? Like, is just a tag with the name trace context and that's it? Or do you want to do anything fancier than that? What does it mean to have basic compliance, for Basic Tracer?
Basic Tracers, doesn't deserve to be in it probably should be in contrib or something, like I think that, like, it's more of a reference implementation than like something anyone is really depending on in a meaningful way that I'm aware of.
Oh yeah, right. And this was just intended to be a reference implementation of how you might parse a trace context header and use it for your own tracing.
Yeah. It's a good question. So your proposal is to parse it and then add it as a tag to the Basic Tracer span, but not to change the main propagation format?
Yeah, I got the impression that's what Yuri was suggesting last month when he said, well, why don't you start out with just, it's in the notes from last month. And I said, yeah, okay, I could split it up. But because I had gone into a more deeper integration where I was just going to change Basic Tracer to do 128-bit trace IDs because it's doing 64-bit trace IDs. And then just, trust naively the sampling bit and everything else.
It's kind of a punt, but another thing, I'm not attached to this at all, but I could imagine Basic Tracer's options that it uses at startup time could include some kind of designation as to which propagation format it's intended to use.
Mm-hmm.
I mean, that XOT span context thing, which was added as sort of like on a whim, I think has actually caused people a lot of anger, which is hilarious to me. It's like we have to choose something. It's a reference implementation, but replacing that, or at least having the option to replace that with the W3C thing, would be completely fine as far as I personally am concerned, although obviously there are other people who might care about it, but then there could just be like a construction time option to initialization time option to Basic Tracer to say, hey, like use the W3C thing as your propagation format. And personally, I think that would be fine. But again, I don't know if Yuri had something else in mind, and I don't mean to dictate it.
No, that sounds fine.
But is part of what you were trying to explore, Chris, was just what if people are in this situation, right? Like it was partial.
Yeah, like I have a tracer that uses a wacky trace ID, but is also OpenTracing compatible. And also, just there exists no actual implementation of the WG standard on the chip that I'm aware of. So that was the other reason for doing a reference implementation.
Yeah.
There's like a half implemented version in Census, but it doesn't actually match the current spec or get
So Chris, like for light stuff, we've made some changes to our own internal format, which is not, no one is claiming to be any kind of standard. And when we've done that, we've basically had, an if-else, thing where we attempt to parse different formats. And that would be another option, to make Basic Tracer prefer the W3C format. And if it's unavailable, to fall back on the XOT span context thing or whatever. I mean, that is another option.
Yeah, I think the original, okay. I think I'll try that then, because that's easier, certainly, than doing it with the weird, I think the original idea was, let's say you go through, I don't know, from Dynatrace to X-ray and back again, and you want to see the trace ID that X-ray put on the thing, assuming everyone's using W3 trace context, and that implementation would have like a good example of how that might work, that scenario. That's a lot more complicated than what but that was the idea of, I think, the reference implementation to demonstrate.
I think it's a great idea, and I think that approach would I mean that scenario you just outlined is sort of the the graduate course level version. Maybe we're talking about the high school level version or whatever. Just
that's what I want to eventually show, is like, here's how you could actually have two different tracing systems with two different trace IDs to sort of interoperate.
I still think you'll need some sort of like a correlation ID tag, because even I mean, even if the tracer supports like W3C fully, sometimes you want to give the user the option to either participate in the trace or only connect to the trace, right?
Right. Yeah, agreed. And that's sort of how the Dynatrace Amazon sort of thing would work. You wouldn't just trust other tracers, or even use their ID. You would just add it as a correlation and then push it into the magic correlation context header.
Well, I certainly think there's value in just the simpler task of just trying to parse that header, like try to actually implement that standard. This is getting into W3C business, but my one concern on that front is there's been lots and lots of talk about optimization. And I feel like in some sense, some of that talk has been focused too much on like the kind of optimization you would get out of building your own custom HTTP client that was like super optimized for grabbing these things. Because again, I think infrastructure developers will do that because it's worth it to them. But I have wondered, like, what are the actual performance implications for everybody else who are going to use this around, like, first you parse the headers and then you got to go into this like trace context header and then parse that thing, right? Like multiple rounds of parsing there versus separate headers. Like some of those optimization debates have felt a little empty to me without anyone like plugging this into Spring and other real systems out there and seeing like what actually happens.
Yeah. No, I just want there to be code that mirrors the spec that they're writing over there, so that people can look at it and talk about it instead of just writing docs.
Awesome.
Okay, cool. See you then.
Great. Okay, I think we're at the end of our hour. This was a great call. Thanks again to the Couchbase people for giving that awesome presentation. And I would encourage OpenTracing people to follow up with some of this W3C work. start getting more involved in that group because they're starting to gel up a bit.
Thanks to you guys for putting the stuff together. We do, you know, do want to work with you, and no reason we can't you know, work together on building some awesome. Thanks.
Excited for the next OpenTracing meetup group. Yeah.
Cool. See you later.
All right.
Bye.
Ciao.